Hello friends, welcome to yet another Facebook live session brought to you by the JEE team here at BYJU'S. Now this is the third Facebook live session that focuses entirely on mathematics. In the first session, we gave you a general insight into the topics that are there in mathematics. We looked at all the topics and we told you where to focus on in order to score more marks in the examination. Then we decided that we are going to give you section-wise analysis. In the previous session, I gave you an analysis of calculus. Calculus, which is the most important section in mathematics because it fetches you lots of questions, was discussed in the previous section. Today we are going to discuss about trigonometry and algebra. Now, unlike calculus, which was introduced for the first time in 11th standard, trigonometry and algebra are not new things for you. These have been carried forward into 11th and 12th standard from your high school days. Trigonometry was introduced to most of CBSE students in 10th standard, and your 11th and 12th standard topics are slightly advanced topics of the 10th standard things. Algebra, well, the history of algebra goes back to pretty old days. We started algebra immediately after you were done with primary. In primary, mathematics was all about numbers. And then came the rogue X. Your teacher introduced you to X. And then life has been all about the perpetual search for X. Mathematics has become find X, simplify for X, and all these things. And this is what algebra is all about. Algebra is about this search for X. So we have done a lot of algebra in our high school. And so the topics in 11th and 12th from algebra are not very intense new topics. These are topics that have been carried forward in a very gradual way from high school. So, it's now time to look at these two sections from the IIT JEE examination point of view. In today's session, I'm going to tell you where to focus on in these sections, why are these sections important, and how can you score quick and easy marks from these sections. First, let's look at trigonometry. Because we have looked at calculus, and I've told you in calculus that a lot of calculus questions actually require you to understand trigonometry very well. So, trigonometry doesn't just give you marks from the questions that come from trigonometry, but it's quite vital in the calculus section as well. So, trigonometry. In your 10th standard, you looked at basic trigonometric identities, you looked at trigonometric ratios, and in your 11th standard, the first unit that you looked at was called trigonometric ratios and trigonometric identities. Here, we brush up your concepts on trigonometric ratios and identities, and then move on to slightly advanced topics such as trigonometric ratios of complementary angles, allied angles, trigonometry ratios of multiples of angles. We also took trigonometry away from the study of just triangles with the help of a unit circle. We looked at what happens to trigonometric ratios in all the different quadrants. And this is where the most famous mnemonic, all silver teacups, came into picture. This is something that will ring a bell with most of you who've seen trigonometry in 11th and 12th standard. The chapter on trigonometric ratios and identities will never fetch direct questions in the examination. But this is the most important chapter because the tricks that you learn in this chapter will be used everywhere. Every chapter of trigonometry and in a lot of problems in calculus. Now, for example, let's look at this particular problem here, which is actually from the chapter on calculus. You are given y, which is a function, and you have to find the derivative of this particular function. The function is, let's say, tan inverse of root of 1 plus x square minus 1 divided by x. Now, this is a differentiation problem, but in order to simplify this problem, you have to use trigonometry. You put a substitution of x is equal to cos theta, and then the whole problem simplifies using trigonometric tricks. And that's why trigonometry is so important, because calculus, which fetches almost 30% of the marks from your in the examination, will have a lot of questions that can be simplified if you know trigonometry very well. So, trigonometric ratios and identities do not fetch direct questions. But this is not the case with the second chapter, which is trigonometric equations. Now, in trigonometric equations, in the past 5 years, 2017, 16, 15, 14 and 13, every year in the main examination, one question has appeared. Now, there are not a lot of topics that we cover in this chapter. In trigonometric equations, we cover one very basic concept, which is general solution to trigonometric equations. Now, every question which comes from trigonometric equations will test your knowledge on general solutions. But in addition to that, there are certain kinds of problems such as finding the maximum and minimum value of a given trigonometric equation. Now, this is a very favorite question of the examiners, especially in the advanced examination. Now, did I tell you how many questions come from equations in the advanced examinations? I don't think I did. So, in the advanced examination, in the past 5 years, 4 questions have come from trigonometric equations. I think it was only in the year 2016 when a direct question from trigonometric equations did not appear in the advanced examination. Also, they ask a wide variety of problems in the advanced examination. They ask integer type of problems. They ask multiple correct answer kind of problems. They sometimes even ask passage type of problems from trigonometric equations. Now, number of solutions in a given interval is yet another favorite question of examiners. So, number of given solutions in an interval, this question is quite tricky sometimes because in order to solve this, you have to understand the basics very, very well. You should understand what is the definition of a general solution of either a sin x or a cos x or a tan x. Only if you know this very well, you will be able to find out the number of solutions which are actually satisfying the equation. So, from trigonometric equations, you always will get one question in the main and one question in the advanced. Then we go on to a chapter which is from 12th standard, inverse trigonometric functions. Now, I love the chapter on inverse trigonometric functions. Not because this chapter fetches questions. In fact, this chapter does not fetch direct questions in the examination. But this concept of inverse trigonometric functions is so important in the unit on calculus that most of the students lose mark in calculus questions from inverse trigonometry because they don't know inverse trigonometry properly. Now, the domain and range of inverse trigonometric functions are very, very important. You should understand that sine theta, where is sine inverse defined, where is cos inverse defined, where is tan inverse defined. You should remember these things very, very well. Unless and until you know these things well, I think it will become very difficult to solve problems from this particular chapter. So, most of the questions which come from inverse trigonometry, be it here, which is a direct question from the chapter, or in the chapter on calculus, you should have a very fine understanding of domain and range of inverse trigonometric functions. Now, there are some other questions which come based on properties of inverse trigonometric functions, and also a few questions come which are based on the sum and difference rules on inverse trigonometric functions. Now, these questions are pretty rare in nature directly from the chapter on inverse trigonometry, but in the unit on calculus again, well, I've been telling calculus again and again and again because trigonometry finds a lot of applications there. So, in the unit on calculus, most of the questions from inverse trigonometry will require you to use the addition and subtraction formulae of inverse trigonometric functions. Finally, let us look at one chapter from trigonometry from where questions actually come from trigonometry chapters itself, from where calculus applications questions don't come. I call this chapter solution of triangles. Some people call it properties of triangles. So, either way, solution of triangles or properties of triangles, this is a chapter from trigonometry which will fetch direct trigonometry questions. Now, the most important concepts here are sine rule, cosine rule, projection rule. Now, in the main examination, there have been questions from sine rule, cosine rule, and projection rule pretty often. 2013, 2016, and 2017. In the main exam, a question was asked which tested your knowledge on these 3 rules. Then the next thing that is very important is a number of formulae for area of triangle is given in this particular chapter. So you should know the different variants for the area of triangle formula, and sometimes examiners test your knowledge of these different variants of the area of triangle formula. Again, questions in the main examination appear from this particular section. In 2014 and in 2012, the question which came from solution of triangles came from this particular concept of area of a triangle. Napier's analogy is another very interesting concept from this particular subunit. Now, the most important bit from this chapter, however, is none of these things. The most important bit from here are different centers and different circles which can be formed inside triangles. For example, circumcenter, incenter, orthocenter, centroid, and the circles which can be formed by taking these centers as the centers of the circles. A lot of questions come from this in the advanced examination. So pay a lot of attention while you understand the concepts of circumcenter, circumcircle, incenter, incircle, and all these things. Normally questions come which involve multiple concepts such as the ratio of in radius to circumradius is so and so. So these are questions where there are not many shortcuts available. I mean, you'll have to know the concepts very well. Only then you can attempt these questions and do them in very quick time. One advice to students who are attempting questions based on circumcenter or any of the centers and circles is that always draw diagrams. These questions become very easy to solve if you draw a diagram and visualize the question. 50% of the question becomes very easy as soon as you can visualize these questions. Now, from trigonometry, there is one unit which is not covered in 11th and 12th, but questions still come from there. This is a unit which is covered in 10th standard, heights and distances. Most of the students forget the concept of heights and distances when they come to 12th standard, and then in the main examination, when a question comes from height and distance, because they have not practiced any question of that kind, they lose marks from here. Now, heights and distances are the easiest questions from trigonometry, and it would be a sin to miss marks from these questions. So, never ever neglect heights and distances. Just brush up these concepts at least once before you go to the examination so that you get these free marks in your kitty. You should never ever lose marks from heights and distances. So, summing up trigonometry. Trigonometry as such do not fetch a lot of questions. At max 3 or 4 questions come from trigonometry in the main examination, 2 to 4 questions in the advanced examination. But does this mean that trigonometry is a unit which you should not focus on? On the contrary, trigonometry is a unit which you must pay a lot of attention on, because the concepts of trigonometry are used immensely in calculus, and sometimes even in algebra, your knowledge of trigonometry is tested. So never ever neglect trigonometry. Trigonometry has a lot of tricks in the units on trigonometric ratios and identities, especially problems such as finding the sum of sine theta plus sine 2 theta plus sine 4 theta plus sine 8 theta. There are tricks to solve such problems. Yet another kind of problem is you'll be asked to find the summation of a general term. Let's say you have to find the summation of sine of 2n theta where n goes from 1 to 20. So you have to find the sum of sine 2 theta plus sine 4 theta until sine 20 theta. Now there are standard tricks to solve these problems, and you should remember these tricks. Even though direct questions don't come from here, some problems will require these tricks to simplify them and do them in very quick time. So pay a lot of attention to trigonometry, solve a lot of trigonometry problems so that you score a lot of marks in the examination. I would say that at least 30% of the advanced and main paper will have trigonometric application. Even though not directly from trigonometric chapters, they will have applications of trigonometry. So never ever discount trigonometry. In fact, pay a lot of attention to it. As much attention as you give to calculus, give it to trigonometry as well. So now we will be moving on to algebra. But before we move on to algebra, let me take a few questions. This way, I think you'll also be able to grasp the things that I told about trigonometry, and you can chill a little before I start giving you an analysis of algebra. So how important is it to remember trigonometric equations? Asked Shaman Rohan. Well, inverse trigonometric equations. In fact, inverse trigonometry, I've already told you, is a very, very important chapter. Questions will not directly appear from the chapter, but in the chapter on especially integration and differentiation, a lot of questions will test your knowledge on inverse trigonometric ratios. You should remember the formulas such as what is tan inverse of x plus y. You should know the formulae for all these things. And you should most importantly know what is the domain and range of inverse trigonometric functions. When it is about inverse trigonometric functions, the only thing that I tell my students is remember the domain and range of inverse trigonometric functions. These are the most important concepts from inverse trigonometry. Now, Shaman Rohan again has asked me a question as to how to remember the derivatives of trigonometric functions with reasons. Well, this is a very interesting question. This is a calculus question, not a trigonometry question. But I'll tell you, in order to remember the derivative of sine theta or the derivative of cos theta, the best way to do it is derive yourself in 11th standard using the first principles. If you derive the derivatives of sine theta and cos theta and tan theta using first principles yourself in your first year, 11th standard that is, then you will be definitely able to remember this. I know a lot of students have confusion as to, is the derivative of sine theta cos theta or minus cos theta? Is the integral of sine theta cos theta or minus cos theta? All these things you will know only if you practice many, many times. Now, I have another question, which is, how should I practice now apart from solving problems to get a decent rank? I have completed the entire course. Well, if you've completed the entire course, you have an understanding of the entire course. It is now time to solve a lot of past year papers. The most important thing to crack exams after you've gone through the entire course is to do past exam papers. Doing past exam papers has multifold benefits. The first benefit is that you understand as to which section do questions frequently come from. Yes, we are doing an analysis here. We are telling you that these are the sections that you need to focus on. But if you do it yourself, it will give you more confidence as to, okay, this is the section from where more questions come. This is the section from where questions do not come that often. So do a lot of past year question papers, because that will boost your confidence, and that will also give you a sense of how long do you take to solve an entire paper. So at this juncture, Abhinav, please solve as many past year papers as possible and focus on sections from where a lot of questions come, and try and find out tricks and shortcuts and keep them in your mind, solve a lot of problems, and yeah, that should help you to solve, that should help you to get a decent rank in the JEE main and JEE advanced examinations. So let's move on. Let's move on to algebra now. I'll take more questions towards the end of this session. Algebra. Now, we've seen algebra right from our high school days, beginning of high school days. We started learning about this rogue X, and we've been following X for a long time now. So algebra slowly progressed. We started looking at linear equations in one variable, then we started looking at linear equations in multi-variables, slowly moved on to quadratic equations and projection and progressions and all these things. So in your 12th standard and 11th standard portion, we have 5 major chapters from algebra. And these 5 chapters from algebra are very important, because a lot of questions come from these chapters. So from 5 chapters, at least 6 to 7 questions come in the main examination, and at least 5 to 7 questions come in the advanced examination. And the thing with algebra is, most of the algebra problems have 2 methods to do. One, the conventional long root method, which you cannot use in the main examination, because main examination is time bound. 90 questions, 180 minutes. If you solve an algebra problem in 5 minutes, you are in grave trouble, people. So, algebra problems, you have to always solve in these competitive exams using the second method, which is the shortcut method. You should know a lot of shortcuts in algebra. I do not have the time here in this session to tell a lot of shortcuts that are available in algebra, but then try and figure out a lot of shortcuts in algebra and keep these in your mind. One very important thing with both trigonometry and algebra is the fact that you need to have very mature, wise, knowledgeable eyes to solve these problems. You should look at these problems, and before you touch your pen, you should understand what is the trick that goes into solving this problem. This comes only with a lot of practice. You should practice a wide variety of problems, and then as soon as you see a problem, you should analyze it. Okay, this is how I should solve this problem. This is the trick that will go into this problem. Because once you apply a wrong trick, it will be at least 2 minutes before you realize that, my train is on the wrong track. And it's too late to come back, because by then you've lost time for 2 questions. So in algebra and trigonometry, make sure that you have wise, mature, knowledgeable eyes, so that you can see the problem, identify which trick to use, and immediately within 30 seconds, arrive at the solution. Now, chapters of algebra. The first chapter is theory of equations, which focuses mainly on quadratic equations. Now, in this particular chapter, the first few concepts are the most vital concepts. General solution of a quadratic equation, nature of roots, and the sum and product of roots. Almost every problem in quadratic equation will require you to use these 3 concepts, for sure. Then there are concepts such as graph of a quadratic polynomial, and also there is a concept such as common roots for 2 different quadratic equations. These are also important. Questions do come from these sections as well. But again, the most important concepts are nature of roots and sum and product of roots. Now, in the main examination, in the past 5 years, 1 or 2 questions have definitely come. 2017, there was 1 question which was based on nature of roots. 2016, there was 1 question which was based on the sum and product of roots. 2015, the question which came was based on, again, a combination of nature of roots and sum and product of roots. 2014 and 13, there were 2 questions each. 1 question was definitely from the concepts of sum and product of roots. The other question was based on the graph of a quadratic polynomial or from number of roots in a given interval. There was also a question on 2 equations having a common root. So these are generally the concepts which will fetch questions in trigonometry, in quadratic equations. Now in quadratic equations, there is 1 trick that I'm going to tell here. This is a trick that most students forget to use in the examination. Now, if there is a problem of the kind a to the power x plus b to the power x is equal to some other a to the power k plus b to the power k, this is a problem which can be done in terms of quadratic equations if a and b are multiplicative inverse of each other. Let's say a is equal to 2 plus root 3, then 2 minus root 3 is the multiplicative inverse of a. So a into b gives you 1. So if you do this using quadratic equation, it takes at least one page to solve this problem. So a problem of the kind a raised to x plus b raised to x, where a and b are multiplicative inverse, is equal to a raised to k plus b raised to k. The solution directly is x is equal to plus or minus k. This is a trick that most of the students don't remember in the examination and end up using at least 5 minutes to solve a problem which you should solve in less than 10 seconds, because as soon as you see the problem, you should understand that the answer for this is plus or minus k. So such tricks are there in plenty in this chapter on quadratic equations. Another trick, a lot of questions testing your knowledge on the sum and product of roots will actually give you a relationship in terms of the difference of root. Let's say alpha and beta are the roots. Then they give you a relation saying modulus of alpha minus beta is less than 4. Students are lost because we don't have a formula for alpha minus beta. But you should always remember that we can convert alpha minus beta into alpha plus beta and alpha beta. What is alpha minus beta the whole square? Alpha minus beta the whole square is nothing but alpha plus beta the whole square minus 4 alpha beta. So, if you know alpha plus beta, which you know, and you know alpha beta, product of roots, if a relation is given in terms of alpha minus beta, you can easily solve this problem. Again, a point where a lot of my students get stuck. So these are things that you will understand if you solve a lot of problems from quadratic equations, a wide variety of problems, and look at a lot of things. Now, if you go through our app and look at the way number of concepts have been covered in our app in the chapter on quadratic equations, we are actually telling you a lot of hints about shortcut methods. So when you're going through quadratic equations, it's definitely a suggestion to all of you to clearly mark these shortcuts that the teachers in the video are explaining. Next, let's look at complex numbers. Now, complex numbers is a direct next chapter after quadratic equations, because one of the roots of in one of the situations when the discriminant of a quadratic equation is negative, you get complex roots. So complex numbers is the next chapter that follows quadratic equations. Now, in complex numbers, a lot of questions comes. In the main examination, every year 1 or 2 questions come. And in the advanced examination also, every year 1 or 2 questions definitely come from complex numbers. Now, complex numbers is an altogether new chapter to you in 11th and 12th. You've never seen complex numbers before you came to 11th and 12th. Now, even though complex number, the chapter has the name complex in it, the chapter is a very easy one. So, the concepts that are covered here are equating two complex numbers, modulus and conjugate of a complex number, argument of a complex number. These are concepts which will fetch lots of questions, and these are very easy concepts. If you know these concepts well, you can very easily solve a number of problems from here. And actually, a lot of questions which come from complex numbers are straightforward applications of the conjugate of a complex number or argument of a complex number. One thing that I've seen students forget is the fact that there are certain shortcuts when it comes to argument of a complex number. For example, if you are asked to find out the argument of a product of 3 complex numbers, they've given you Z1, Z2, Z3. What students do is they find out the argument of Z1, Z2, Z3, they multiply Z1, Z2, Z3, and then find out what is the argument of the product of the complex number. In fact, argument of Z1, Z2, Z3 is nothing but argument of Z1 plus argument of Z2 plus argument of Z3. The same thing goes for the division of two complex numbers also. Argument of Z1 by Z2 is argument of Z1 minus argument of Z2. These are things that you should remember. Again, in our videos on 11th standard topic on complex number, this thing has been covered very well and they've repeatedly mentioned these things. So keep this at the back of your mind when you go into the exam hall so that you can save a lot of time in the chapter on complex number. Now, rotation of complex number and De Moivre's theorem. Now, De Moivre's theorem will fetch you a lot of questions. De Moivre's theorem is something that is used to find out the nth root of a complex number or the nth root of unity. So these are things which you have to pay more attention on because the questions can be tricky here. For example, if you have a complex equation of the form a plus ib to the power n plus a minus ib to the power n, you have to use De Moivre's theorem here. And when you use De Moivre's theorem and solve the whole thing, it is going to take a lot of time. So this is where there are certain shortcuts that are available, certain formulae that you can derive and then remember. So in complex numbers, make sure you solve a lot of problems because most of the problems are easy. Some tricky problems which with practice will become easy and routine. Again, complex number is an important chapter. Lots of questions come from here. The next chapter is a chapter from where questions don't come. But this is a chapter which is very, very important because the concept of this chapter is used everywhere, all across mathematics. This chapter is inequalities, logarithms, and modulus. Very important chapter. Very few concepts are covered here, such as properties of mod, properties of log, definition of mod, and then inequalities. Now, if you don't understand the concepts in this chapter, I cannot help you because these concepts are going to be used everywhere. This chapter cannot be neglected even though direct questions don't come from there, because this is a chapter that kind of forms the fundamental of inequalities, log and modulus. Now, when it comes to the concept of inequality, there is something called as the wavy curve method. Now, wavy curve method is very important, and this method is the easiest way to solve a lot of inequalities, especially when you have an inequality involving a ratio. When you have a numerator by denominator greater than or equal to 0, you have to use wavy curve method. Otherwise, you will be stuck solving for n number of cases and it will take you a lot of time. So make sure that you understand the concepts of this chapter in great detail. Then we move on to a chapter which I like a lot because sequences and series are things that I liked even in 10th standard, and they don't become extremely complex in 11th and 12th as well. You look at AP, you look at geometric progressions, harmonic progressions, arithmetico-geometric progressions, and also you look at means. So the most important bit in this particular chapter is the relationship between means. Most of the complex questions which come from this chapter come from the relationship between arithmetic means and geometric means. Now, in fact, if you understand the concept of arithmetic mean and geometric means, questions from trigonometry also can be solved using this concept. A lot of questions where you have to find the maximum value of a trigonometric equation or a minimum value of a trigonometric equation can be solved using the concept of arithmetic mean greater than geometric mean. So, sequences and series will in itself fetch questions. Every year there's one question which comes in the main exam from sequence and series, and in the advanced exam 1 or 2 questions come from sequence and series. But in addition to that, the concepts in sequence and series find application in trigonometry as well. So, even though this is an algebra chapter, I say that this is a chapter which finds application in trigonometry. So, focus a lot on arithmetic means and geometric means. Focus a lot on geometric progression and the sum of n terms of a geometric progression or sum of infinite terms of a geometric progression. Again, geometric progression is a favorite topic of examiners, and among all the progressions, most of the questions come from GP. Also, there are questions in trigonometry which will involve concepts of GP. So make sure that you know the relation between the means as well as GP very well. Doesn't mean that you can neglect arithmetico-geometric progressions or harmonic progressions or arithmetic progressions. Everything is important, but the most important ones are relation between means and geometric progressions. Finally, binomial theorem. The binomial theorem is again a new topic. Just like complex numbers, you've not seen binomial theorem in your 10th standard. So this is a topic that is introduced for the first time in your 11th standard. So binomial theorem again is quite a tricky chapter. Questions which come from here are rather very tricky, and a number of times students will not even understand how to go about with a problem. There are certain formulae that you should remember. For example, you should remember that NCR plus NCR minus 1 is equal to N plus 1 CR. This is a formula which has to be used in a number of problems. Again, you have to use the formula NCR is equal to N by R multiplying N minus 1 CR minus 1. Now, for example, there is a problem where you have to find the summation of R NCR. Now, one way to solve this is using differentiation of binomial expansion, but then that is not a very favorite method of mine. If you know this formula, which is NCR is equal to N by R, N minus 1 CR minus 1, you can solve this problem very easily. Now, just like I mentioned in the beginning of this particular session, to solve problems from binomial theorem, you really need very wise, knowledgeable eyes which has seen a lot of problems. Because most of the problems in binomial theorem is about analyzing. You have to look at a problem and you have to analyze the problem. As soon as you look at a problem and analyze it before you pick your pen up, most of your work is done. So solve a lot of problems from binomial theorem. It's a chapter which fetches one question definitely in the main examination and one question in the advanced examination. So I hope you have a lot of fun when you learn trigonometry and algebra. And of course, if you have any queries with trigonometry and algebra, you can write to us. Also, you can go back and look at all our videos. Most of the concepts have been brilliantly covered in our videos. So if you look at these videos, you'll have a lot of fun learning these chapters. Of course, you can write to us. We have a doubt clearing sessions wherein we'll answer most of your questions. And it's now time to answer a few questions that have been dropped by my viewers. So, there is Anup Sai who's asked me the same question that somebody else asked in the beginning of the session, which is how to remember inverse trigonometric functions. I don't understand how to remember, because inverse trigonometric functions is all about understanding domain and range. Once you know what is the domain of an inverse trigonometric function and the range of that function, it's as good as you've remembered the concept of inverse trigonometric functions. Now, there's Mushir Inamdar who's asked me, is de Moivre's theorem useful for JEE main, and how to solve big trigonometric problems and problems of special series in some time or minutes to get good score in JEE main? Oh, long question. But yeah, de Moivre's theorem is very important, because de Moivre's theorem will fetch you questions based on the nth roots of unity or the nth root of a complex number. So de Moivre's theorem, you have to understand it very well, and it's a concept which fetches definite questions in the examination. Another question he's asked me about is special series. Yes, this is the thing that I forgot to mention about sequence and series. Now, in special series, we have questions such as summation n square, summation n cube, and all. So all these have standard formulae, and again, these are questions that you can solve very quickly only if you do a lot of practice. So it's important that you solve a lot of these problems and make sure that you have a fine understanding of all these concepts. Well, I think it's time to stop this particular session because we've already exceeded 30 minutes. I hope you have a lot of fun when you're doing questions from these two units, and you score a lot of marks from the questions that come from this unit. In case you have any queries, please drop the questions in the comment section and I'll answer them in the following days. Thank you.